a bit of a housekeeping if you're not on not presenting, which might going on mute, please. And there will be opportunities throughout to ask any questions. Okay. So, few introductions for the team. I'm Matt. I manage the quote team for NEM, LV, DG, or HV, DG, anything up to 1,000 kVA. So all of this work stream is managed by me and my team. Over to Nick.
Just unmute myself.
Yeah.
Just deal with the echo.
Yeah, so Nick Blair, head of connections quotations. So Matt reports into me, as does I do the rest of the teams that work through quotations. So that's anything from domestic through to large embedded generation and demand projects, with the exclusion of low carbon technology, which Maz, who's going to introduce herself, manages.
Simon.
Hello, my name's Simon Stickley.
That's me. Sorry. There we go. I've turned off.
Yeah, I'm HV Strategic Planning Manager, and we assist connections, Matt Safka's team, for new connections, point connection studies, and also for the compliance for P28 and G5 and G99.
Hi, so my name's Mary Claire. All right, we've lost the reverb. My name's Mary Claire. I am the Low Carbon Technology Design Manager. So we sit slightly separate from the rest of our connections teams. We deal with all low carbon applications, whether they be reactive or proactive, for all domestic properties.
And Paul.
Thanks, Matt. Good afternoon, all. My name's Paul George. I work within the DSO side of the business. In particular, the focus for the team and myself is delivering capacity management strategies, which is predominantly through flexibility services and flexibility procurement.
Thanks. And last but not least, we've also got Tracy Taylor on the call. She isn't down to present, but is there if you've got any specific charging questions? Okay.
Good morning, everyone.
Right. So moving on, a very brief update for you all on our A&M, which we've been working on. So A&M is automating network management. So a bit of a background to this. ENWL, as with most other DNOs, we always build and designed our network for the worst case operating. It's narrow. So by that, I mean in peak demand, minimum generation, or low demand and peak generation. Okay, with the growth of demand on our network, so with things like all low carbon technologies, our network capacity needs to increase. So to do this, we can't just reinforce and put in more circuits, larger rated plants or cables. It's simply that would be too expensive and take too long for the energy transition. So whilst a traditional approach does have its place, we also need different solutions. So one of those is A&M. So where there were a constraint on our network, typically the customer can't connect until the network has been reinforced or get a different POC, which most of the time the alternate POC is more expensive, both for the customer and also us, and takes longer to deliver. So typically, when the constraint often only occurs in certain times of the year when the networks are highly loaded or running abnormally under a fault condition. What A&M does is exploit the fact and allows customers who are willing to be dynamic with their load to connect in normal running conditions on the basis that they will agree to be constrained during abnormal running. So A&M is a bolt-on system to our network management system, and it's a mix of hardware and software that will allow us to remotely constrain customers. So as a example, what we've got on the right here is a typical seasonal load flow throughout the year. So as I've said, traditionally our network were designed on peaks, whether that be summer or winter, and it leaves large periods of the year with unutilized capacity in our network that could be offered to customers who are willing to be dynamic with their loads. So by deploying real-time A&M systems, we can make the most of the headroom available. So all the while, we will still need to maintain the limits and manage the network, so i.e. not tripping any breakers or exceeding assets. So if you look at the green period where we've got a low demand, for example, this will be ideal for EV chargers or batteries to deploy. Similarly, the red peak, that will be ideal for generators to export back on the network and flatten that peak. So what A&M does is it monitors the current flow, power, voltage, reactive power, both the feeder ahead, but also at the customer's sites. So on a a schematic, a HV schematic. That would mean we would monitor the power volts amps, both at the primary breaker transformer, but also at the customer's sites, and dynamically adjust the load within the agreed threshold. So this solution is currently only available on the HV network, but we are working on LV solution. Don't have any timescale on that, but reason why we've mentioned this today, I thought better give you a update, is that we know that many of you also operate on the HV network as well. So if you've got any customers, and this is ideal for generation, because generation typically is a bit more dynamic and flexible than some of the traditional demand sites. If you've got any customers who are willing to be flexible with their load, this solution may well work for them. Okay. Before moving on to Paul, is there any questions on any of that? No? Okay. Paul, you're next, if you want to take control.
Thank you, Matt. Good afternoon, everybody. Thank you for attending today's session. So as I mentioned in the intro, Paul George, I'm the DSO commercial lead here within the business. Now, before I kind of go into our suite of flexibility services and what it means and why it's important and where we use it, I just kind of thought it was worthwhile just setting the context in terms of what's happening across our network. So UK kind of wide, we're seeing a real evolution in terms of how energy is, how it's generated, how it's distributed, how it's purchased, how it's traded, and how it's used by kind of end users and consumers. So kind of the top kind of swim lane on the slide on the screen is the more traditional way in terms of what was happening from an electricity generation perspective, transferred onto the transmission network, follows through to the distribution network, which is then delivered into homes and businesses across our region. What we're seeing is we talk about the transition, we talk about kind of the evolution of what's happening in this space. So the second swim lane at the bottom is again from generation to transmission to distribution, and we need to think of more innovative ways in which we manage the network, mainly due to the fact that homes and businesses now will have a lot of kind of distributed energy resources. It may well be kind of solar panels or behind the meter generative assets, CHP. There'll be additional kind of demand assets on there like EV chargers and heat pumps, electricity storage. So essentially that one-way flow of traffic of electricity through the network from generation, transmission, distribution to the homes and businesses, that's evolving, and we're seeing kind of a multi-directional flow of power across our network. So this is really where kind of the DSO team that I operate in kind of see our main body of work in terms of how can we make sure that the network is smart enough, it's efficient, and kind of manages this kind of multi-directional flow of power onto the network, and really kind of taking advantage of all the assets that sit behind the meter again, be it community energy focused, or you know, EVs and heat pumps and solar panels. With that kind of change in the system, obviously, you know, I'm probably preaching to the converted with this, but there's a lot more kind of electrification demand upon our network. So the slide that you can see on the screen really looks at what's happening from our kind of forecasting team out to 2040. So again, just to pick up some of the, you know, the key themes on this is that what we predict is that nearly 1 in every 2 dwellings is expected to have a heat pump, again, be it commercial or domestic. We know there's a lot of focus on residential new builds to kind of have these technologies. Obviously, when the houses are being built, as opposed to retrofitting, customers are projected to consume twice the amount of electric energy as they do today. So that's from where we are today out to 2040. And again, anticipated that nearly 9 out of 10 customers that are currently behind the wheel will be driving an electric vehicle. I think it can be subjective in terms of some of these numbers on the screen, in terms of, you know, how many EVs will be on the road, or how many heat pumps will be in play in commercial and domestic. A lot of that is largely driven through policy with the boiler upgrade scheme, and the speed of the acceleration of transport and heat decarbonisation. That will impact those numbers. But I think it's fair to say is that whilst there's some subjectivity in terms of how fast we will get there, this is the direction of travel. So out from where we are today to 2040, we're kind of looking to see more than double the amount of electricity being used upon our network. So we need to think of, like I say, innovative ways in which we can support that growth of the network, which will deliver net zero to customers and to local authorities and all the stakeholders that sit across our region. So that's the kind of background in terms of what my team do and some of the changes that sit on the network. Just to give you some more granularity on the previous slide. So we are looking to both encourage and support a big uptake in low carbon technologies on the network. So this is a breakdown of the different kind of technologies that will be connected to our network. So again, we've touched upon that we can see from where we are today out to 2040, nearly double the amount of electricity that's going to be used, which again is largely driven through the uptake of EVs and heat pumps. By 2030, you know, there could be 1.3, well, it's anticipated there could be 1.3 million EVs in the Northwest, which is 8 times the 2024 volumes. A big important factor in this will be where those EV chargers are located. And again, you know, the critical factor being the speed of those chargers, are the AC chargers, the DC chargers, which will impact and determine, you know, what that impact will be on our network. Again, the forecasted numbers on the screen there also considers not just kind of domestic vehicles, it's looking at electric vans, buses, coaches, and heavy duty vehicles as well. From a heat pump perspective, again, while the exact timing is still relatively uncertain, we are going to see a significant increase in heat pump adoption between 2030 and 2040, potentially up to 2.3 million in our service territory of the Northwest. So again, as I've mentioned earlier, the speed of this transition will be largely governed by what happens from a policy perspective, the boiler upgrade scheme. So there's increasing certainty that longer term heat pump volumes will be reduced as well, as heat networks will be developed in some areas, and we are seeing that in the Northwest currently. From a DG capacity perspective, you can see 1.6 gigawatts today versus a projected 2.9. So again, we're looking at an increase there of up to 40% of renewable generation is expected to hit the network, and that could even be quadrupled by 2050. So even higher levels are required if regions need to accelerate decarbonisation or transmission connected renewable projects are delayed. From a battery storage perspective, we're looking at a 5-fold increase of storage by 2030 and up to 15 times more by 2040. And again, further out, 17 times more battery storage out to 2050. So while the majority of regional volumes are primarily driven by large grid scale batteries, we do foresee a rise in the adoption of domestic batteries as well. So I think Matt mentioned earlier on the previous slide around some of the challenges that we face. So this energy transition that we talk about will undoubtedly create challenges for us as a network operator. But the positive aspect is that it will absolutely create opportunities for our regional stakeholders. So we've got a range of options that we're looking to support that increased demand that's hitting our network. Option A, as Matt mentioned, so we're an engineering company at heart, so building new assets is our sweet spot. However, the traditional reinforcement and asset build, it can be disruptive, it can be timely, and it can be costly. And again, thinking about the exam question of how do we as a business keep costs down for our customers, options B and C are probably the more appropriate and economical options for us as a network. So at ENWL, we're focusing on 2 clear pathways to keeping down those costs whilst building simultaneously the network capability. So option B, there's an opportunity for us to be more innovative while still delivering network capability. We can deploy new technologies that allow us to extract more capacity from our existing network infrastructure and delay the need for option A, which is about building new assets. So probably worth mentioning on that point is within the DSO team, we're looking at kind of non-wired solutions. We're looking at very simply, we've got this increased demand that's going to hit the network. How can we squeeze more capacity for the network to support more low carbon technologies without building new assets and, like I said, bumping up costs for our customers? Option C is where my team kind of really call upon stakeholders that sit within the region. So we're thinking about third-party flexibility. So we see flexibility services as a key enabler for the DSO transition. I mean, put simply, this is about rewarding customers for shifting when, where, and how electricity is consumed or generated, which helps us balance peak demand and delay the need for option A. So ultimately, by asking customers or asset owners to shift how they use power or how they generate power, can really help us solve that question of, to build a bigger network and extract more capacity, how do we avoid costs of going to reinforce the network? So with that in mind, flexibility services, what are they? What are the types of flexibility services? There's kind of 3 key buckets, if you like, of what we call upon. So naturally, you've got demand reduction. There's generation as energy efficiency. So demand reduction, kind of typical demand side response. So this can be looking at or utilizing EV chargers, turning down and being more prescriptive as and when they're being used. There's lots of different technologies that sit on EV charging infrastructure nowadays, be it load management, smart charging networks. There's lots of ways that users of EV charge can be much more kind of mindful of how and when those EV chargers are being used. For an industrial commercial customer, it can be turning off or shifting intensive processes. We see an awful lot at the moment of businesses, if they can turn down the demand of their assets or shift the processes to off-peak times, that can have a significant impact on the demand on the network, and it can be controlling heating systems as well. From a generation perspective, again, it's thinking about those distributed energy resources, renewable generation, battery storage. It can be tapping into customers that have standby generation And one of the key themes that we're seeing emerging at the moment is those kind of big industrial users. They've got standby generation that they have to run, obviously, to check the certificates that it's up and, you know, it can be called upon and it's running as it should be. So we're encouraging businesses that have standby generation to run those generative assets at times of stress on our network. They've got to run them anyway, so why not run them and turn off their input capacity at times of our network and get paid for doing it. The other bucket is energy efficiency measures, and this is really low-hanging fruit for a lot of customers. This lends itself really well to customers that don't have energy resource intensive processes. So it can be warehouses, office blocks, and this is really just about continuously pulling down and reducing their peak demand on the network. So we see a lot of businesses now that have installed solar. They could be putting LED lighting in, could be retrofitting the building to install LED lighting. They could be looking at building fabrics, so building insulation, or even kind of modernizing equipment to be more efficient that sits within their premises. And they're the kind of the three, like I say, three buckets that we can kind of call upon that can help us deliver flexibility services. And for that as well, so we ask for the support of, be it aggregators, be it big industrial commercial users, local authorities, it can cover schools, NHS. We can help them understand what the art of possible is, quantify how much flexibility they can give us through those various kind of measures, and more importantly, what we can pay them for helping us do that. Last slide from me is, how does the flexibility procurement process work? So we operate 2 tenders a year. So we've got 2 biannual flexibility services tenders. We go out with a set of requirements, as you can see on the top right. We've got the kind of requirements out to the end of our ED2 period from 2026 to 2028. You can see the breakdown by our kind of 3 sub-regions, which we class as Cumbria, Lancashire and Greater Manchester. You can see the amount of megawatts that we're looking for in those particular sub-regions, the number of requirements that we have, and more importantly, the size of the prize. What money is available for delivering that amount of megawatts as flexibility? So we've got over £12 million available for people that have assets, that optimize assets, that can participate in our flexibility tenders. Apologies for the kind of timeline at the bottom. You can probably see this pertains to our October or autumn tender. But I can tell you at the time of doing this, we hadn't finalized the dates, but I can tell you that the 15th of April this year, we will launch our spring tender, but the timelines kind of remain the same in terms of you can commercially qualify and upload your assets at any point. On the 15th of April, so replacing the 31st of October, the tender will open. You can upload your assets and put kind of the technical capabilities of the assets, so thinking about the response times and how fast they can respond to kind of those notifications from us to say, look, you know, we need this at this time. The commercial qualification will close, technical qualification will close, and then participants can say, yes, we will participate in this tender, and then they can put some bids in. So they can say, or you can say, look, we can give you 1 megawatt, and we expect a payment of X from ENWL for delivering that. Then we go through a process of evaluating the bids, and then should the bid be economical, we will basically award a contract that says, okay, Mr. Flexibility Provider, you said you can give us 1 megawatt during these times of day, during these months. We will pay you X pound per megawatt hour for doing that. Worth noting as well is that before our autumn 24 tender, this was really looking at the EHV network, but we're developing our suite of products now to really kind of get into the low voltage network. So on our spring tender, we've got 63 location secondary substations on the low voltage network to make it much more inclusive, to kind of help us manage the network from the bottom up. We only have, worth noting, we only have a threshold of 10 kilowatts as well, both on EHV, HV and LV. So if you've got an asset that can deliver 10 kilowatts of flexibility, it can participate. Be that through one asset or be that through an aggregation of a number of assets, it doesn't matter. If we can get 10 kilowatts as a base threshold, it can participate in those tenders. So like I say, that tender goes live on the 15th of April this year. And we're encouraging, like I said, from a domestic perspective, we see a big rise in domestic flexibility, industrial commercial users, local authorities, asset builders, asset developers, asset optimizers. And this can also be, because we put our requirements out to 2028, this doesn't have to be an asset that's energized today. So again, thinking about the representation from the connections team on the call, if there's any planned assets in the region that aren't energized as of today, but will be online in, for example, 2027, 2028, they can also participate in these tenders. So if you're going through a connection planning application and you've got an energization date of 2027, it can still participate in this current tender because we've got like a forward view then of potential participants in the tender. So that's kind of a really quick whistle stop tour of our flexibility products. Again, if there's any sort of deep dive or kind of one-to-one sessions that you might want, we can certainly take it offline and have a conversation around what we can do. We have a range of constraint management zones across the network. So they're the substations where we have flex. It's not kind of ubiquitous across the whole of the network. There's certain parts of the network where we put these tenders out for, so we can help you identify and pinpoint where those parts of the network are, and more importantly, the requirements. So the amount of flexibility that we need, the times that we need it, and again, how much you might be expected to get paid should you deliver, whatever flexibility can be delivered. So happy to answer any questions on that. I appreciate they kind of rattle through that, but again, the offer is open to anybody that might want to kind of take a discussion offline to learn more about what we're doing and how we can partner with some of our stakeholders across the region.
Thank you, Paul. And just on the follow-up, we will be sharing a feedback form at the end of the meeting, and there is a box at the bottom there to add any comments. So if it is something which you're wanting to explore further with Paul, by all means, drop a comment in there, and we'll feed that back to Paul and set something up.
Thanks, Matt.
Thank you. Okay. Right. Couple of very quick day-to-day points which we wanted to raise. So first one, whenever we get generation, and specifically on new housing schemes, we do often get the demand. However, the generation is left off or left until the last minute. So if you are working with any developers, please encourage them to add on the details, what they're wanting to put onto each house, and share that with us early, ideally when we're first looking at the network. We have had schemes where without no mention of any generation on any of the application, design, offer, acceptance. So we're in a contract with a developer or a delivery guys go out on site and there's PV on the roof and it can lay the connection. So please work with your developers and share that with us early. Next one, if you or your customers are willing to limit the export, please advise us what they are willing to limit it to on the application. This is often we have back and forth with likes of the installers, and it just saves time. So if you know what they're able to limit it to, share that with us. Final ask is please return the commissioning documents. It is often overlooked a bit of the job and process, but it is important that we do get those so that we can close out the job and formalize everything. Okay. Okay, turning next to Simon, who's gonna give you a overview on G5 and P28.
Thanks, Matt. Good afternoon, all. I'll just launch straight in. So I suppose first sort of question is, why do we need to comply with G5 and P28? So as a DNO, we've got a statutory obligation to maintain power quality and comply with regulations. And it's also detailed in G99. So to comply with G99, you also need to comply with P28 and G5. So I'll talk briefly about P28 and then I'll focus most of the time on G5. So to demonstrate compliance with P28, we typically only request this for larger generators, so type B G99 schemes, which is larger than 1 MVA or 1 megawatt. So if requested, a generator would need to demonstrate compliance with voltage step change, rapid voltage change, and flicker. And yeah, we do some assessment of that on the quotation stage, just to ensure that no generator connected is going to sort of impact voltage step change. So that's why we do that. And so I'll move on to G5. So G5 is relating to harmonics on power systems. So firstly, what are harmonics? So it's AC current or voltage waveforms at different frequencies to the fundamental frequency. Harmonics are multiples of the fundamental frequency. So for example, the second harmonic is 2 times 50 hertz. So it's at 100 hertz. And then we've also got interharmonics, which are non-integer multiples of the fundamental frequency. So say 1.5 times the fundamental. And then a bit of a introduction to the electromagnetic compatibility concepts. So here we've got a diagram of a typical distribution system. So we've got system disturbance level, which is what we'll find on the distribution network, and then equipment immunity level, and that's the level of harmonics that equipment can withstand. And so we've got planning levels, immunity test levels, and then compatibility level in the middle. But where we've got a crossover of disturbance level and immunity level, that poses an issue where we could have customers' equipment failing because it can't deal with the level of harmonics. So that's something that we're trying to avoid. So this is the sort of more what we're looking to achieve at a site level. So we've got just site disturbance level, which is the transmission network, and then we've got a planning level, which is where we ask for any equipment added onto our network to be less than that. Then we have a further level of compatibility level, which is sort of like the very maximum we can go as a network. And then we have local immunity level. So you can see consumers' equipment is well below the disturbance level that we've got on the network. And so that's sort of key points of what we're trying to achieve here. So just go on to how to actually demonstrate compliance with G5. So it's a staged approach, and if you fail at one stage, you move on to the next stage. So firstly, the point of common coupling is where the assessment needs to be made. So that's where like the connection is onto our network. And the system impedance from the connection to the voltage source affects the harmonics, and it's related to the short circuit power at the point of common coupling. So for the first stage, stage 1A, is for equipment that's less than 16 amps per phase, and is it compliant with BSCN 61000-3-2? And if so, then it's okay. Then that's all you need to do. Check that it's compliant with that equipment standard. For the next stage, stage 1B, is the equipment compliant with BSCN 61000-3-12, and is the short circuit power within limits. So this is for equipment between 16 amps to 75 amps per phase, and it must meet a calculation for the permitted power of the equipment. And to demonstrate compliance with this, you'd need to know the actual short circuit power, and that can be requested by the DNO. So from the DNO. As if it doesn't meet those requirements, say it fails at 1B, you move on to 1C. Which is slightly more complex. It introduces different converter technologies, and again, the equipment power is calculated, and it must be less than the actual short circuit power of the site. Now, it's important to note that 1C, that 75 amps is about 50 kilowatts of for 3-phase. So if you've got single inverters that are 50 kilowatts plus, then you're straight in at 1C stage. Failing 1C, you move on to 1D. This requires background harmonic data. Again, this is requested from the DNO, and I believe there's a fee to pay to get that. And this requires a calculation of the fifth harmonic headroom. And then if that doesn't pass, then that goes on to stage 2C. So I say fifth harmonic, that's particular to inverter technology. If you've got different types of technology, then it does actually go on to different harmonics, but that's the main one that we see related to solar PV and batteries. So just briefly talk about stage 2C. So to do this, the customer needs to obtain the background harmonics, obtain the system fault level or the short circuit power, and then follow the steps in G5 to verify each imposed voltage harmonic is within the planning limit, and then also the total harmonic voltage distortion is within the planning limit. And normally we'd expect that to be delivered in the form of a report, which which would come to us to review. So that was a whistle-stop tour of G5 requirements, and P28 is, unless we've got any queries, I'll pass the laptop on to Michael.
I was going to say, I don't know how clearly you can see me with the, is that better? That's better. Okay, so I'm going to talk a little bit about the Connect Direct app today, and what it can actually offer installers as well as ourselves as DNOs. So the Connect Direct app was launched by the ENA back in May 2024. And as you can see from the chart there, each month, more and more applications are coming in via this method now. It supports both all forms of LCT technology, so EV, HP, mixed applications, PV and battery storage as well. So it does allow multi-device applications. So if you are installing not only battery, but PV, all on one application. If you're installing EV and HP, again, one application. It allows for ease of communication between installers and DNOs and also the end customers as well. As you can see there, it allows for different states within the system as well. It's been built as an API background. So a lot of what comes into it actually gets auto approved, which means us as a DNO to have no interactions. All we do is record it on an internal database instead. And it allows for fast, easy answers and applications. With regard to the generation side, it also holds a data bank. So it holds a data bank of all compliant devices that the ENA have already checked. This means that us as a DNO are not having to request multiple times, because as the installer, all you need to do is upload the device that you're going to be installing. The ENA do manage this site, and they do have regular engineers checking these devices. It allows, if one's not on the database, as an installer, you submit an application to the ENA via the Connect Direct portal. They will complete all the assessments and either deem it to be on the compliant list or the non-compliant list. It also allows us DNO to actually view applications in real time. If I was to log onto the portal now, I would see all applications up to 1 minute ago. So it is a real-time portal. It's fast, it's free to installers and all LCT manufacturers. And as I said, if each application meets certain preset criteria, it allows for instant auto approval on the system. It reduces the risk of missing data, and it reduces the risk of delays in processing as well, as if all the data that's required is not attached to the initial notification or application, it will be automatically rejected. Now, at the minute, we're working on a development of the portal, whereby it will allow installers to actually save as they go along through the application until they are ready to submit. It will also allow amendments up to a 4-week period after the DNO has approved, meaning that if anything changes, say you've put your application in before and you get to site and you can't for whatever reason install that device that's already been pre-agreed at a domestic level, then it means that you can make amendments and we as a DNO can actually re-approve. This is due to be launched later on in the year. We're undergoing testing just at the minute. As I said, on the database, it allows for all devices to be stored. The descriptions here of the resolved applications are based purely on the PV, battery and multi-devices. And as you can see, from the information that we're receiving at small scale for fast track, these are being DNO approved. We are working on increasing these criteria at the minute so that it improves this auto-approved rate. The compliance list is managed and assessed by full qualified E&A engineers, which means that any device on there has already gone through all of the checks that were previously talked about with regard to meeting the BS standards for harmonics, and fully assessed no matter where they've come from based on all the criteria that is set out in the EREC for G98, G99 and G100. I've not put too much in about the Connect Direct app, but I thought I'd leave it open for any questions that anybody may have. And I actually have on my laptop some more information. It is worth going onto the E&A website and taking a look at this. It's not just for domestic properties. It is being upgraded all of the time. And the more it's used, the more abilities it will have. Does anybody have any questions? No? Right, I'm going to
Is it worthwhile just adding it? We're using that up to fast track levels.
So we are using up to fast track levels for this at the minute, but it does have built in the scope more if all DNOs, because it's based on all DNOs, agree that it could actually have the ability. Now, I just saw a question flash up.
Does a hybrid inverter count as PV or battery storage?
Ooh.
Repeat that yourself.
Yeah, so the question was, does a hybrid inverter count as PV or battery storage? Now, within the Connect Direct, it would go down as a multi. Within ourselves, a hybrid is more likely to be classified as a battery than it would be a PV. However, it would depend on what the device is. Any more questions? I can't see anything popping up. I'll give everybody a chance just to type them out. Oh, all right. Laptop will go for a quick flight. There we go.
Thank you. Right, thank you all. Any final questions? No? Right, okay. The ask from you all is to please fill in the survey. Nick has kindly posted it in the chat. We'll also share the slides. It's only 4 questions, very quick, but we would very much welcome your feedback on this. Okay, and it'll help shape future events as well. Okay. Final call for any questions? No? Right, okay. Thank you all for joining. I hopefully found that informative, and thank you and bye.